The motivation of using the Wheatstone bridge in RTD is because in RTD the resistance is produced. Okay, so by producing resistance, there is noise, there is heat, noise resulted. So that we need to convert it in terms of voltage by using a Wheatstone bridge circuit. Okay, and the Wheatstone bridge here, as you can see, this is the well-known diagram of a Wheatstone bridge. Mainly, we have three resistors. R1, R2, and R3, R1, R2, R3, and we will have additional R4. So in the fourth resistance, this is what we are going to replace it with our RTD. So please check the video if you want to see in more details explanation. And in both points, point A and point B, so we put a current here so that we can measure the V output, the voltage. So the voltage at point A and the voltage at point B, you can formulate it as follows. So the voltage at A is equal to V times R3. So VA is simply the output voltage. Okay, so the V coming from here, V coming from the reference. Okay, so V times R3 divided by R1 plus R3. Okay, so VB at point B, you do it the same. So B, because B is in between R2 and R4, so that you can find this VB. Well, this is actually the final results. If you want to know in more details how can you get these final results, you can go to the video for more detailed explanations. Right, so the difference output between point A and point B. So point A and point B, this is what we get as an V output. Right, so this V delta V here, you subtract the first VA minus VB. Depends. You can subtract VB minus VA, that's okay. But in a balanced situation, in equilibrium situations, we want both to be null, to be zero. So if both VA and VB 0, so that we'll get this relation. Resistance 1 times 4 equal to resistance 2 times 3. So in this condition, in the balanced condition, let's say I know the value of R1, R4, R3, find the value of R2. But in most cases for RTD, remember R1, R3, and R2, they are known. And our task is finding, for example, R4. Or even R4 is known by measuring the temperature. Your task is finding what is the voltage. It can be that way. Okay, so in a simple way, it is defined as like this. So we have the resistance of the Wheatstone bridge. So this is the Wheatstone bridge with 100 ohm, 100 ohm, and 100 ohm. And here we have the RTD. The RTD here is obtained from the measurement of the temperature. Then with the difference, with the temperature difference, there is a resistance difference, let's say 50 ohms. And here is the the voltage that we want to know. Okay, please remember why we are using Wheatstone bridge, because resistance is not a valid measurement. That's why we have to convert it into voltage. So this is what we want to get. This is the voltage that we want to get. Okay. All right, so in simple way, we may formulate it this way. So RA are the resistance from the RTD divided by RA plus resistance from RTD minus half. Let's take a look when the R1 of R is the actual RTD. You can take a look here in the figure. So we have a Wheatstone bridge, R1, 2, and 3. Then remember there is a one resistance wire here. It is now replaced by RTD. This is our RTD. Okay, this is what we call as a two-wire RTD, L1, L2. Well, basically L is in the unit of ohm, but let's imagine that L is a notation for resistance for cable 1, and L2 is resistance for wire 2. Right, and then we want to know what is the V out or delta V or whatever you may call it. This is the simplest configuration of RTD. This is quite cheap with 2 cables. It is used when the lead wire is short. In previous several videos, you may have seen how we plug the thermocouple in real life. Let's say in a big factory, right? Because it is very big, you may need a very long wire. But if it is not that big and it is quite short, then you can use 2 wires RTD. Okay, when the cable length is longer, then it means it will have influence. Definitely, if you remember in your class of electronics parts, if I'm not mistaken, there is a relation between length, current, resistance, and voltage. Now let's take a look here. When the condition is in balance, is in equilibrium or no voltage between point here and point here. So you can recall the previous formula. You can recall the previous equations, which is here, right? This is our equations for balance condition, equilibrium conditions. It's just that the notation now is different because it becomes R3. It is no longer R4, okay? So R1 times R3 equal to R2 times, this is what we have for using 2 wires. Okay, this is quite easy, right? So if R1 is equal to R2, so if R1 equals to R2, so you can cancel out. So it means the RTD should have the same resistance with R3. And how can we find the V out, the output voltage? So it is equal to delta V Vs. Vs is coming from the source, coming from the reference. We can call it reference or we can call it source. Is equal to this formula. All right, now what we can conclude from this RTD, two wires RTD with the Wheatstone bridge. From the equation R3 equal to L1 plus RT plus L2. You may want to check out in the book what is this R3. The R3 will be the resistance, material resistance. And I'm sorry for the previous statement that I made. So L1, L2 here is the length, the lead wire length. So now let's take a look at an example for two wires RTD. So for two wires RTD, we have all the values. Now the L1, L2 now is in terms of resistance, in terms of ohm. All three resistance are 1, 2, and 3. They have equal values, 150 ohms. But for the RTD, the two wires L1, L2, although it is already converted into ohms, into resistance, and the length is no longer shown. So L1, we assume that L1, L2, they have the same value, which is 50 ohm. And now the RT, coming from the overall RTD here, is varying from 50 up to 80 ohms. And the V reference or the source is tenfold. The questions, what is the V, the output voltage of the RTD? So here, this is what we want to get. This is the output measurement of our temperature, is the voltage. What is the V out sensor RTD by using two wires? Because we are varying it from 50 up to 80. So you can try to find the V output one by one from RT equal to 50 and RT equal to 51 and so on. Okay, to find what is the V output. How about RTD by using three wires? So RTD by using three wires is almost the same as before. It's just that we have three wires here, replacing the second wire. So we have L1, L2, and L3. And we always have this RT. And this configuration is quite well known in the industries. And L2 is attached to minimize the resistance to L1 and L3. So previously we have L3 coming from this point B, if you remember. And there is also here coming from, let's say, point F, L1. So if we want to minimize the resistance of both lead wire, so you can attach L2 in between. So in this configuration, it is possible to make a setup of lead wire up to 60 meter. So imagine this is quite long. Imagine if we have a very big, let's say, gas chamber or any furnace, metal furnace, Then we want to measure what is the temperature, but it is very big, so we can use this RTD of 3 wires. In the null condition, source balance condition, the equilibrium, so it means the voltage, the output voltage should be equal to 0. By recalling the previous equations, then we may get this. If you still remember, okay, R1 times R3L, 3L2. Why? Because we consider only this point. That's why we only have this. And the other one is L1, L2, which is coming to the upper parts, coming from here. How about the output voltage? The output voltage is what we are interested in. So the output voltage is basically like this. So we have the reference or the source voltage. So the output voltage is here. Okay, one may ask me, one student asked me, why do we need the source voltage? Do you remember our previous meetings? Probably in the video I have given you in the week 1 or week 2. There are 2 types of instruments. There is passive and active instruments, if you remember that. So in active, it means we need to generate electricity first. We need to generate some voltage to get the results or to measure something. So this RTD is one kind of active instrument. While in passive instrument is like thermometer, like the one you use in the hospital. So we don't need another source to measure something. So from the 3 wires RTD, what can we conclude? It's a bit different because we are using the third wire, light wire, the third light wire. So it means the resistance of L1 and L3 can be minimized. This is somehow typo. So the resistance between L1 and R3 can be minimized. And the same, find what is the output voltage for the 3 wires RTD. If the resistance RT is varied from 50 up to 80 ohm. You can use the previous equations and try to do it. Okay, so you use these equations, the output voltage equations, and try to find what is the output voltage for different value of RT from 50 up to 80 ohm. In RTD, it is possible to find 4 wires configuration in RTD. And this because it is using more wires, so it means it is most accurate to measure temperature. But using more cables, using more wires, so it means it is not that cheap. And this method increases its accuracy and reliability of the measurement results. Using another cables or using additional cables, additional wires, its purpose is to reduce another wire's resistance. but it is used mostly in the lab scale, only at the lab. It's not cheap and it uses more cables, so it is mostly used in the lab. Like in a thermocouple, there is a color code for the wires. You should check that. I may have given you in one of the video. So in thermocouple always uses two cables, two wires, and there is color code for thermocouple. For example, yellow and red, yellow and blue, and so on and so on. So it shows something, and it is standard. So there is no thermocouple using random color without following the codes, without following the standard. In RTD, it applies the same. There is a color code for the wires. Well, if you are using copper, you know the copper is a copper color. But what I'm talking is this cable is wrapped. It's wrapped with a plastic, with a color plastic. So this should be standard. The same in RTD, the wires, it can be using any wires, platinum or copper or any types of wires, nickel, but those wires should be wrapped with standardized color, plastic color. Okay, in two wires, RTD, there can be red and white. It is used where the lead length is short, definitely two wires. Remember the previous slides, two wires are mostly used for short distance. And there is no compensation for resistance of lead wires. Okay, and for the three wires, there is a white, red, and red. Most common type of RTD in industry and typically connected to a standard bridge circuit. And it allows lead wire resistance to be compensated. I have explained this to you. So the third lead wires is there. It exists to compensate high resistance of other wires. And the four wires configurations, white, white, red, red. It has higher accuracy, and the resistance errors can be eliminated in this configuration by measuring the voltage across the RTD element. And RTD of two wires RTD, for example, it may have errors in two wires RTD. And the source of this error can be, the first one is the accuracy, the choice of accuracy. You remember what's the definition of accuracy? You should remember this. And also the sensitivity. These are characteristics of instruments. And also the resistance of the insulator. It has a shunting effect. So the insulin, there should be an insulator in RTD. You remember the configurations, the structure of RTD, there is always insulator. And the insulator should have resistance, adequate resistance, so that RTD can function properly. And the repeatability, stability, and shock and vibration. Shock and vibration of the measured components, are also the self-heating. The heat is not coming from the object, that we measured, but the heat is coming inside the RTD. For example, not sure, probably it's too long, the wire is too long, and the current is too high, and so on and so on, so that the heat is generated. So it is self-heating. Another example of self-heating, one of the error. What is the error in the temperature measurement by using platinum RTD? If the temperature is 100 degrees Celsius and self-heating is about 50 milliwatt per degree Celsius in the water. So we measure water by using a platinum RTD, and this water is flowing with some flow debit. Okay, and the current is about 5.10 power minus 3. Okay, so here we want to know what is the heat generated first, the overall heat generated, and from here we may divide it with the self-heating, the known self-heating, 3.5 divided by the self-heating power by temperature. So the error, we may say, so our RTD has an error about 7 times 710 power minus 3. You know, this, we may call it 7 times 10 power minus 3. Okay, 7 times, usually in the measurement field, we want to focus more in this. So degree Celsius. So 10 to the power minus 3. Is it too big? Is it too small? Well, it really depends on the RTD that we are using. What is the accuracy of the RTD that we are using? The calibration is also one of the topic that I have given in the previous meetings. After talking about characteristics of instruments, you've learned about calibrations, how to calibrate the RTD. You can take a look here. This is not something difficult to understand. To calibrate the RTD. And how about other thermal sensor? So in the book of Curtis Johnson, you may find RTD, thermistor, and also thermocouple. There is a thermocouple in the book of Curtis Johnson. So I was mistaken before. There is thermocouple in the book. So other thermal sensor, there are many others, bimetal stripes and gas thermometer. We may use gas thermometer instead of using metal. We may use vapor, pressure thermometer, liquid expansion, or solid state temperature sensor. So each form of thermal sensor has its own function and has its own application. So mostly by using the like thermocouple or thermistor or RTD, mostly because our applications have very high temperature. Okay, so you can read this on your own, one by one. What is the solid state temperature, bimetal stripes of thermal sensor, and so on. So the bimetal stripes of thermal sensor here, you have two metal stripes like this. They are joined together like in the figure, or it can be in the helix form like this. Imagine you have a helix metal, but there are two metal bimetal helix. So if you hit one of the edge, it will expand it. It will be expanded like this. So it will show what is the degree, temperature degree, the object that you are measuring. And the comparisons of a thermal sensor, you can find it here using thermocouple, RTD, thermistor. I don't give you our thermistor in more detail. You can take a look from the book of Curtis Johnson, what is thermistor, and you can even take a look in available videos when you have to use thermocouple and when you have to use RTD, when you have to use thermistor, and so on. Okay, and thermocouple, this is self-power. It is simple. It is not expensive. This is quite cheap compared to others. And temperature is quite wide. Let's say you want to measure from -100 and up to 550, you can use thermocouple. But in RTD, the range is quite small. But it is more stable. It is most accurate, which means it is more accurate than thermocouple. And in thermistor, this is high output. It is fast, quite fast. So you can read the graph. So you can compare three of them. What is the difference between thermocouple, RTD, and thermistor? They have their own disadvantage and advantages. In thermocouple, low voltage, it is not that stable, least stable and least sensitive. In RTD, it is quite expensive. As you know, this is most stable and most accurate. And we need current source. We need output source for this. And it is exposed to self-heating. For thermistor, it is highly nonlinear. Temperature range is quite limited, and also it is quite fragile. Some applications of thermal sensor, it is available in the market, and it can also be used in several applications. Affordable with high performance thermal tracer using the infrared thermal imager. You can take a look at this in more details. You see from distance, from the remote distance, we may measure the temperature, the feature, visual, and thermal image. The same here, you see there is a generator or a turbine that we want to control the temperature of the blade. You should always control the blade's temperature, you know that. And we may use the infrared thermal sensor instead of using, for example, the RTD or the thermocouple. We may use the infrared thermal sensor, and we can detect. You see, let's take a look in the left upper figure first. So from among the 6 wires installation, so the third wires here is quite high. The temperature is quite high, so we may need to replace for this. The same here. This is a pump, isn't it? So this is the figure. This is the photo here, and we want to know which part is the most heated, and we can see here. So this red color shows which part is the most heated, and so on. Here you can also take a look here, and also here, this is for, I think it's a pipe installation. So infrared thermometer that you just have seen, it measures mostly about radiations emitted from the object. So it measures mostly the radiations, the heat radiations from the object. And the emissivity of the surface should be known first. Otherwise, we may have more errors. And also because we are measuring the radiations from a long distance, from the remote distance, it means reflections from surroundings may have a big influence. Okay, so how can we decrease, how can we eliminate this reflection? So when you try to measure it by using infrared thermal sensor, all the surface of the object should fulfill of your thermal sensor. Okay, it should fulfill all, let's say, all monitor of your thermal sensor. Okay, so for others here, you can read it in more details by yourselves. It's not too difficult to understand, and you can also check the book from Curtis Johnson. All RTD, thermistor, and also thermocouples are available in the books. All right, so don't forget to try solving the problem of Wheatstone bridge. Let's say you are having two wires, what will be the output voltage? Or if you are having 3 wires, what will be the output voltage? Try to do it yourself as an exercise so that you will understand. All right. I think that's all for today, and we'll meet again on Monday. Monday will be our first quiz. The scope from our first meeting about characteristics of instruments and a little bit about calibrations and thermocouple. How can you find the temperature or the voltage up to today about RTD and most probably about Wheatstone bridge. And don't forget on Monday, I am making a Zoom meeting on Monday at 4 because the quiz will begin exactly at 4. I will open the meeting before that. So I will open the meeting from 3:45. So you may join from 3:45. Then we'll start the quiz together exactly at 4. Okay? That's it for today, and thanks for coming. See you on Monday.
Bu, izin tanya, Bu.
Yes?
Izin pakai bahasa Indonesia juga, Bu.
Ya?
Mau tanya tentang yang tadi yang triwire, Bu. Maaf, Bu, boleh share screen lagi nggak, Bu?
Oke, saya. Biasakan menggunakan saya ya.
Iya, Bu, maaf, Bu.
Oke. Ada yang ingin ditanyakan apa?
Tentang ini, Bu, yang tadi yang triwire, Bu.
Oke, silakan.
Bentar, Bu. Izin share screen, Bu. Permisi, Bu. Udah terlihat, Bu?
Ya?
Mau nanya, Bu, di sini saya agak bingung di bagian yang mana ya? Ini, Bu. Untuk L2 ini, Bu, kenapa bisa ada di kanan dan di kiri ya, Bu ya? Di persamaannya, Bu.
Oke. Ini kamu kembali ke persamaan sebelumnya dan coba kerjakan. Ya, coba kembali ke Wheatstone Bridge. Nah, di sini ya. Kembali ke sini. Kalau kita hanya mengukur voltage di poin A saja, berarti kita punya R1 dan R3 ya. Kemudian kalau kita hanya mengukur di poin B saja, kita punya R2 dan R4. Kemudian kalau VA sama dengan VB, artinya mereka dibuat kondisi equilibrium. Maka jadilah R1 kali R4 sama dengan R2, R3. Nah, kalau ke yang 3 wires, coba ke 3 wires. Nah, yang di 3 wires ini hampir sama. Ya, kita punya R1. Oke, yang 3 wires ini kan kita ada R1, R1, R2, R3, kemudian ada 3 couple ya, L1, L2, dan L3. Nah, poin yang terukur di sini antara R1, poin yang terukur di sini kalau kita ambil poin di sebelahnya L3 di situ, dan yang satunya dari sebelah kiri kan V out ya. Kita punya bentar, saya gambar dulu. Saya nggak bisa gambar ya. Coba saya yang share screen ya. Saya stop dulu. Oke. Oops. Oke, tunggu. Sudah kelihatan ya?
Sudah, Bu.
Oke, kita mengukurnya dari di sini ada L1, L2. Jadi ini V out yang terhubung. Nah, seakan-akan dia yang ambil dari poin ini. Itu ya. Kemudian ini L2. Kemudian kalau kita mengukur dengan kabel yang lainnya, maka kita mengambil V out, dia terukur dari poin L3 di sini. L3 kemudian L2. Karena kan yang kita ukur adalah titik ini ya. Jadi masing-masing antara L1 dengan L2 terhubung pada V out atau L2 ke L3 yang terhubung terhadap output voltage ini. Nah, di sini kan ada awalnya, maksudnya ini kan rumus akhir ya. Nah, coba kalau dikerjakan seperti yang bridge tadi kan dikerjakan satu-satu ya, per poin gitu. Nah, kalau VA dulu di sini ada A dulu berapa, kemudian B berapa, kemudian baru disamakan antara A dan B. Sama dengan hal ini dikerjakan dulu masing-masing, kemudian baru disamakan sehingga ini bentuk paling sederhana. Oke, ada pertanyaan yang lain?
Ya, Bu, izin nambahin lagi, Bu.
Ya.
Ini kan kalau saya lihat, Bu, ini kan bentuknya kan kayak segitiga gitu ya, Bu ya. Apa namanya rangkaiannya? Itu yang untuk yang L2 tadi apakah independen, Bu? Jadi nggak apa-apa ditaruh di dua persama, maksudnya di ruas kanan kiri. Soalnya setahu saya pas SMA itu kalau nggak salah diajarin buat bisa bikin hambatan pengganti gitu, Bu.
Maksudnya gimana?
Saya lagi, Bu.
Oke, silakan.
Ini, Bu, jadi kan kalau misalnya saya gambar gini ya, Bu ya, ini kan L ini ke arah RT, ini ke arah L3, 2. Kalau seingat saya dulu, Bu, kalau nggak salah ini bisa diganti jadi tegangan pengganti gitu, hambatan pengganti gitu, Bu. Nah, yang saya bingungin apakah L2 ini memang independen, Bu, jadi bisa nggak perlu dibuat tegangan pengganti, jadi bisa langsung dimasukin kedua gini, Bu.
Hambatan pengganti itu maksudnya apa?
Jadi ya yang kayak gini kalau nggak salah Bu ya, seingat saya bisa diganti jadi bentuknya kayak segitiga gini, Bu. Diubah apa namanya bentuknya, jadi ntar hambatannya begini, Bu. Kalau saya tidak salah, Bu.
Itu kan hanya pertimbangan dia, itu hanya hambatan ya. Yang kamu pelajari itu sama dengan Wheatstone Bridge nggak? Atau hanya sekedar rangkaian dari kabel hambatan?
Kalau seingat saya
Seperti di
waktu itu,
fisika dasar.
iya di fisika dasar tentang Weston Bridge ini, Bu, pas belajarnya, Bu. Atau mungkin saya salah aplikasi, makanya saya mau
Atau
percaya ke Ibu.
apakah disebutkan detail Wheatstone Bridge ya? Kalau di fisika dasar seingat saya enggak ya. Di fisika dasar itu sekedar dia rangkaian kabel, rangkaian kabel, kemudian ada hambatan, baik itu kita bisa bilang itu apa namanya paralel, serial, kemudian kita ganti atau yang kamu sebut sebagai pengganti itu. Saya kurang jelas apa yang kamu maksud di sini, tapi di sini spesifik pada Wheatstone Bridge. Jadi ada poin-poin yang maksud saya poin itu ada antara R1, R2, di situ pertemuannya yang kita sebut tadi sebagai voltage di titik A, kemudian R3 dan R4. Ini kalau Wheatstone Bridge yang pertama ya. Kemudian R4 kalau di case ini diganti menjadi 3 wire RTD. Nah, kemudian kenapa ada L2 di situ? Tiba-tiba keduanya ada di situ. Ini diturunkan mengikuti yang pertama tadi dulu. VA. Kalau lihat gini seakan-akan kok tiba-tiba ada di sini ya, tapi tanpa mengerjakan. Ya, coba mengikuti yang Wheatstone Bridge tadi pertama. Kalau dari poin yang kiri, kemudian pengukuran juga dari yang kanan. Dalam keadaan kondisi seimbang atau nol, VA sama dengan VB itu. Oke?
Baik Bu, berarti ngikutin sama yang kayak persamaan sebelumnya Bu ya?
Ya, ini penurunannya sama seperti persamaan Wheatstone Bridge yang sebelumnya.
Baik Bu, terima kasih banyak Bu.
Sama-sama. Oke, sebentar. Oke, kalau gitu untuk hari ini cukup sekian. Kita ketemu lagi hari Senin ya. Hari Senin jam 4, seperti saya tadi bilang, jam 4 kita mulai quiz, jam 4 pas, sehingga usahakan sebelum quiz kalian sudah gabung. Jam 4 kurang seperempat saya akan buka Zoom meeting, jadi silahkan gabung jam 4 kurang seperempat, absen dan lain-lain, sehingga jam 4 sudah bisa gabung. Jam 4 kurang 10 lah, kurang lebih ya. Oke, anyway ini kelas bahasa Inggris, jadi saya berharap yang bertanya pun kelas bahasa Inggris ya, kelas Y. Kalau nggak salah setahu saya kelas Y ini dengan sadar kalian daftar masuk ke kelas Y kan, artinya kan kalian berharap ingin bisa bahasa Inggris dan kuliah dalam bahasa Inggris kan gitu. Ya kalau enggak ya saya mending bahasa Indonesia aja. Tapi ternyata ini kan kelas Y. Kelas ini diadakan karena memang untuk improve. Kita sama-sama improve ya. Oke, cukup sekian untuk hari ini. Kita ketemu lagi hari Senin. Terima kasih semuanya. Jaga kesehatan.
Terima kasih Bu.
Baik, terima kasih Bu.
Thank you, ma'am.